Welcome to Future Doctor NEET Academy for the problem solving session in NEET Physics. Topic chosen today is from chapter 13, Nuclei. Already we have floated 7 questions in the previous session. Now we are going to solve the solution for these 7 problems. Let's move to question number 1. The half-life of a radioactive sample undergoing alpha decay is 1.4 into 10 power 17 second. If the number of nuclei in the sample is 2.0 into 10 power 21 nuclei, the activity of the sample is nearly dash. I think most of you got answer. Option A, 10 power 4 becquerel. BQ is becquerel. That is the correct answer. Formula used here is activity equal to lambda into N. Here lambda is the decay constant or disintegration constant and N is the number of nuclei in the sample, and T equal to 0.693 by lambda, and your T value is given 1.4 into 10 power 17 second. T equal to 0.693 by lambda, then lambda equal to 0.693 by T. What is T? T is half-life, is a given value 1.4 into 10 power 17. Then substitute this lambda equal to 0.693 by T here. That is 0.693 by T is 0.693 divided by T is 1.4 into 10 power 17. Then substitute this lambda value here in this lambda. Then activity equal to lambda is 0.693 divided by T is 1.4 into 10 power 17 into N. N is, this is a N, 2 into 10 power 21. Then 2 into 0.693. This 0.69 you can keep approximately as 0.7. Then activity equal to 0.7 into 2 is how much? 7 into 2, 14. 0.7 into 2, 1.4. 1.4 divided by 1.4, and there 10 power 21, and this 10 power 17 comes up, then 10 power minus 17 into 10 power minus 17. 1.4, 1.4 getting cancelled. Then 10 power 21 minus 17 is 10 power 4. Therefore, activity equal to 10 power 4. Unit of activity is becquerel. That is only BQ. Becquerel, that is option A. Option A is the correct answer. Let's move to question number 2. For a radioactive material, half-life is 10 minutes. If initially there are 600 number of nuclei, the time taken in minutes for the disintegration of 450 nuclei is dash. Actually, decayed part equal to N by N naught. N is the number of atoms in T time and N naught is the initially number of atoms present at T equal to 0. Initially that is only N naught. Okay. And N naught is given 600. N is given 450. Then undecayed part equal to 1 minus N is 450 divided by N naught is 600. Then 600 minus 450. How much? 150. Then this is equal to 150 by 600. 0, 0 getting cancelled, and 15 4 times. This is equal to 1 by 4. 1 by 4 is nothing but 1 by 2 power 2. And this is equal to 1 by 2 power N. From this we can find this N. Okay, 2 power N. 1 by 2 power 2 equal to 2 power N. From that N equal to 2. N equal to 2. Then substitute this here and you want to find half-life is given, I think 10 minutes. Yes. You should find T only. Small t. Small t equal to N into capital T. Capital T is the half-life. Then N equal to 2, substitute. 2 into T is 10. Already, even in answer also, you want to substitute, you want to find it in minutes only. So no need to convert into SI unit. Then 2 into 20, 2 into 10, 20. 20 minutes. That is option C. Option C is the correct answer. Let's move to question number 3. Here also formula same, but method is different. The half-life of a radioactive substance is 30 minutes. Yes, T is given 30 minutes. The time taken between 40% decay and 85% decay of the same radioactive substance you want to find. Same formula only we are applying. Undecay part equal to 1 minus N by N naught. Same formula only. And 1 minus 40%, that it will be N1. N1 equal to 1 minus 40%, that is 40 by 100. 1 minus 40 by 100 is 100 minus 40, 60, 60 by 100. 0, 0 getting cancelled. Then 6 by 10 is 0.6. And N2 equal to 85%. 1 minus 85%. 85 by 100. Then 100 minus 85, 15. 15 by 100. Then it gives 0.15. Then N2 by N1. N2 by N1 equal to 0.15 by 0.6. Then it gives 4 times. 1 by 4 equal to 1 by 2 power 2. 2 power 2, that is equal to 1 by 2 power N. From that N equal to 2. N equal to 2. And here also you want to find small t only. T equal to N into capital T. And N is 2. And capital T, that is only half-life. How much? 30 minutes. 30 minutes given. So 2 into 30. Then T equal to 2 into 30, 60 minutes. 60 minutes, that is option D. Okay, option D is the correct answer. I think most of our students not getting answer this. This is the correct procedure. Let's move to question number 4. The number of beta particles emitted by a radioactive substance is twice the number of alpha particle emitted by it. The resulting daughter nuclei is and dash. Is isotope or isotone? Isotope is correct. Let's check it. Let the element is X, Z, A. What is Z? Z is the atomic number. A, mass number. X is the element. And here, as per the question, one alpha particle is emitted. Alpha particle is nothing but helium nuclei. So, under alpha decay, what will happen? That is, atomic number is reduced by 2 and mass number is reduced by 4. That is the alpha decay. And 2 beta decay minus 2 beta decay. Here 1 alpha and 2 beta decay. In beta decay, how is it? Atomic number is increased by 1 and there is no change in the mass number. And here 2 beta particle, so 2 atomic number increases. So Z plus 2 becomes Z into A minus 4. So initially X is at A and here X is at A minus 4. So what is that? Same atomic number and different mass number. So what is the name of that element? That is the element which is having same atomic number but different mass number, that is isotope. So isotope of parent. The daughter is a isotope of the parent. That is, this is a daughter nuclei and this is the parent nuclei. Let's move to question number 5. The radius of germanium nuclide is measured to be twice the radius of beryllium, Be49. The number of nucleons in germanium or dash. Formula is R equal to R naught into A power 1 by 3. And 2 nuclei is given. So R1 equal to R naught into A1 power 1 by 3. And R2 equal to R naught into A2 power 1 by 3. And radius of the germanium nuclei is measured twice. That is R1 equal to 2 times of R2. And R1 by R2 equal to, R naught will be getting cancelled. R1 by R2 equal to A1 by A2 whole power 1 by 3. And A1 only we want to find, and A2 is given. What is the A2? 9. Is it so? In BE49, 4 is the atomic number and 9 is only mass number. So 9 is given. Then R1 by R2. R1 equal to 2R2. Substitute 2R2 by R2 equal to A1 we want to find divided by A2 is 9. 9 whole power 1 by 3. R2 getting cancelled. Then 1 by 3 come this side. What you will get? That is when 3 goes that side, 1 by 3. 1 by 3 comes this side, power 3. That is 2 power 3. 2 power 3 equal to A1 by 9. Or A1 equal to 2 power 3 is 8. 8 into 9. 8 into 9 is 72. 72. 8, 9, 72. That is option D. Okay. So germanium nuclide, the number of nucleons for germanium is 72. Let's move to question number 6. A free neutron decays into a proton, an electron and a dash. Let's write the nuclear reaction. Neutron. Neutron is N01. That decays into wait. Free neutron decays into proton. Proton is P11 plus electron. Electron is beta particle, beta or E minus 1, 0 plus antineutrino. Antineutrino is the correct answer. That is a nu bar. Neutrino is a nu 00. Antineutrino is the antiparticle of the neutrino. Therefore, antineutrino is the correct answer. Let's move to last problem. The nuclei C613 and N714 can be described as dash. Isotones, isobar, isotopes of carbon, isotopes of nitrogen, which is correct answer. Yes, isotones is correct answer. What is isotone? What are isotones? Isotones are the elements having different atomic number, different mass number. Then which will be same? Neutron number will be same. That is, we know the formula, general formula, that is X, Z, A. How can you find neutron number? That is N equal to A minus Z. That is only neutron number. Then first for carbon, C613, for that neutron number equal to 13 minus 6 equal to how much? 7. Let's check for nitrogen. Nitrogen N714 gives N equal to 14 minus 7. That is equal to 7. Okay. So, same neutron number. Different atomic number, 6 and 7. Different mass number, but same neutron number. That is called isotones. So, option A, isotones is the correct answer. In next session, we will float 7 questions in the next chapter, and next session we will solve the solution for that concerned questions. Thank you students.